This is Geometry, Unit 8, Day 9. We're working on the worksheet for angles and arcs. We're going to start with this figure. I'm going to suggest to find all the information about it before we start answering the questions. Here we have two diameters, so that means we have some vertical angles. This is going to be 42. We know the two arcs. These are central angles because the vertex is at the center. The central angle and its intercepted arc are the same measure. So 64 and its arc is 64. This is a diameter, so we know that all three angles here are going to add up to 180. So if we take 180 and we subtract the 106, we're going to get 74. So we'd have 74 and 74. What's missing on this side would be 108 minus the 42, which is 138. And that's also going to be its central angle. From there, we should be able to answer all these questions. So, the measure of arc PQ is 42. The measure of arc ST, 74. The measure of arc TPS, it's all the way around, T to P to S, everything but the 74. So one way we can do it is to say 360, not counting the 74. Okay, so that should add up to 286. So 286 is going to be a major arc. The 42 is going to be a minor arc because it's less than 180. And 74 is a minor arc because it's less than 180. It's a major arc because it's over 180. The measure of arc STQ, that is exactly 180. And one way that we know that is because SQ is a diameter, so the arc that goes from endpoint to endpoint of the diameter is also 180. So that's a semicircle. The measure of arc RQS, it's all the way around, but not including this 42. So one way to do that is to say 360 minus the 42. So that's going to give us 318. And again, that's going to be a major arc because it's over 180. The measure of arc QR, that's going to be 138. Anytime you have two letters, you know that that should be a minor arc. The measure of arc PQS. So you could either add up what you don't want and subtract that from 360, or just add up what you do want. So from P to Q to S, that's going to be 42 and 138 and 42. So that's going to add up to 222. and that's going to be a major arc because it's over 180. The measure of arc TQR. That's everything but what we have down here. Or you can add up the different values across the top. So we're going to get 244. And that's a major arc. The measure of arc PQ. The measure of arc PS. That's the 64 and the 74 put together. So that should be 138, which is a minor arc. The measure of arc PTR is the measure of all three of those, but notice that PR is a diameter, so you know that all three of those add up to 180. So we call that a semicircle. That is half the circle. We're going to find the indicated measure. We're looking for the measure of arc AC. Well, here we have AC, and we notice it's the same as this one. Here's a right angle, so that makes that 90. The other two are the same to each other, and together they make up 360. So we know that we have 360 total. We're taking away our 90 to give us 270. Then we're going to break that into two equal pieces. So we're going to divide that by 2, and that's going to give us 135 apiece. So that makes our arc that we're looking for 135. If all three arcs are exactly the same, then we're going to take 360 and divide that by 3, and we'll get 120 degrees. So all three of these are 120, which of course adds up to your 360. Here we're looking for the measurement of angle DAB. So we're going to take 180 and what's ever left over here to get up to the B. DAB. Well, if we have a right angle, which makes that 90, the other two have to be the same measurement. So here we have 180 degrees. It's a semicircle because there's our diameter. So you could say 180 minus your 90, which is 90. Now we have the last two angles that are going to add up to 90, and we divide those by 2, which is 45 apiece. So now if we're going to go from DAB, we know that that's going to be 180 plus the 45, which gives us 225. For our next question, we're looking at a water sprinkler, and if you notice, the water sprinkler is hitting almost 180 degrees. It's 180 degrees, but it can't quite get to 5 degrees over here and also 5 degrees over here. So we'd say 180 minus the 5 minus 5 more, which gives you 170 degrees. So what is the measure of the arc covered by the sprinkler? It would be 170 degrees. If the sprinkler starts at the far left, how long will it take it to work its way all the way until it gets as far as it can to the right? Well, we've seen up here that it moves through the covered area at a rate of 5 degrees per second. 5 degrees per second. So if we take the 170 degrees that it should be traveling and we break that into groups of 5, then we should know how many seconds that it's going to take. So we'll notice that that gives you 34 seconds. We're going to find the measure of our indicated angle or the arc. So here we're looking for arc TS. Well, all we know is that this angle is 61. If that angle is 61, then I know the intercepted arc is double that. There's 122. Then we're going to look at our diameter and say that we have a semicircle on this side, so 180 minus the 122 is going to give us 58. So we know that the measure of ST is going to be 58 degrees. We're looking for the measure of arc AB. AB is on this side. Well, the angle that we know is 20. So it's an inscribed angle. So we know that the inscribed angle equals half the measure of its intercepted arc. The inscribed angle equals half its intercepted arc. So, in other words, you take the angle and you times it by 2. The angle is half the arc. So if the angle is 20, the arc is 40. And again, we have a diameter. It goes through the center, it goes straight through. So 180 minus the 40 leaves you with 140. The measure of angle JLM. We're looking for this angle here, which would be equivalent if we knew this arc here. Well, not equivalent, I guess. We would have to take half of it. But if we could figure out this arc, then we could figure out what our inscribed angle is. Well, if our central angle is 88, then we know that it's 88 for the arc. Here we have a diameter, so if you subtract from 180, you're going to get 72. Actually, not 72, sorry. That's going to be 92. So we have 92 here. If that's 92, we need to take the 92, divide that by 2 for us to figure out that we have 46. Notice again that we have an inscribed angle. The measure of the inscribed angle equals half of its intercepted arc. Over here we're looking for the measure of angle A. For us to figure out angle A, then we're going to need to know what this arc is, because angle A is going to be half of its intercepted arc because it's an inscribed angle. Well, there's our diameter. If that's 54, then this is 180 minus 54. which is going to be 126. And if this is 126, then this is going to be half of your 126, which is 63. The measure of angle JKM, we're looking for this angle. We know that if two inscribed angles intercept the same arc, then those two inscribed angles are the same measure. So that would be good enough to answer the question, really. But let's think about it like this. If we have 28 for the inscribed angle, the intercepted arc is going to be twice that. The angle is half the intercepted arc. The arc is double the angle. So we know this is 56. Now if we go this way, we know that this is 28. So 2 inscribed angles intercepting the same arc are congruent. So both of these, angle L and angle K, are both intercepting the same arc, so they're congruent to each other. We're looking for the measurement of VST. We want to know all of that. Well, that's funny the way that they've written this one. They've called it VST. But VST is most likely going to be less than 180. They didn't need to use 3 letters there. VT would have been enough. So that's kind of a miswrite. The notation's not correct. But anyway, if we're working with the angle, we know that it's an inscribed angle because the vertex is on the side, and the intercepted arc is going to be twice that. So this is 102. If that's 102, then we know that the remaining amount is going to be 360 minus these two. So 360 minus 102 gives you 258 minus another 135 gives you 123. That would be, really, we could call that the measurement of VT, arc VT. On the other side, we're going to look for the measurement of X. Well, here we're actually working with expressions rather than just numbers. We know that the angle equals half the measurement of the intercepted arc. So the measurement of angle BAC equals half of this large arc. So I'm going to throw another letter over here just so we can label that. Let's call it D real quick. So BDC, because I want to name it correctly through the large arc. So that's 5x equals a half of 9x plus 21. Well, one way to get rid of our half is to distribute it, but both of those are odd numbers, so taking halves of them are decimals. The other way, we can multiply both sides by 2. So this is going to become 10x, and this, the half drops out because we multiply it by 2, and if you double a half, then you get the value of 1. Now we'll subtract the 9x over, and x is going to be 21. On this side, we notice we have 2 arcs. Both of those arcs are intercepting. We have a green arc. Well, actually an angle. That's an inscribed angle. We have 2 inscribed angles. And a red inscribed angle. They're both intercepting the same arc, which is right there. And we know if 2 inscribed angles intercept the same arc, then they are congruent. So that's going to make the 2x plus 11 equal to the 4x minus 3. We'll subtract the 2x to the other side. And add the 3. That gives you 14 divided by 2. That'll come out to be x equals 7. Here we're looking for the measure of angle 1. Well, we know that the measure of angle 1 equals half of our 2 arcs. We have a blue arc and we have a red arc. So we know that the angle, the measure of angle 1, equals half the big arc, 243, minus the small arc. Well, what's the measure of the small arc? 360 minus 243 gives us 117. Lots of people make the mistake and they say that the answer is actually 117. But 117 is just that smaller arc. Now we sure to plug it into our equation. When we subtract those two, we get 126. And take half of your 126. So the measurement of angle 1 is going to be 63. Same storyline here. If we take the 360 around the whole circle, we can find out what this missing part is. So we're going to subtract the 138, which is the small arc. And when we do that, we're going to get 222. So we know the large arc is 222. So in this case, the measure of angle 1 equals half of the big arc, which is 222, minus 138. So we know when we put those two numbers together, we get 84. Take half of that, we get 42. That looks like something we did in our notes. Number 26. Now this looks a bit tricky because we actually know what the angle is. What we don't know are what the arcs are. Well, we're going to set it up the same way. The angle equals half the big arc minus the small arc. the angle equals half the big arc minus the small arc. So the angle is 61. The big arc is 10x plus 1 minus the small arc. Now when you do minus the small arc, you need to be sure to put that in parentheses. So really it's 61 equals half of 10x plus 1 minus the 5x but plus the 1. When you distribute that negative through, you've got to say minus 5x, but you also got to say a negative and a negative make a positive. Now we can collect our like terms, and we know that 10x minus 5x gives you 5x. A positive 1 and a positive 1 gives you a positive 2. Again, I don't want to take half of 5x because that gives me a decimal. So I'm going to double both sides. Subtract the 2. And when we divide by 5, we'll get 24. Our last question is about a satellite that's up in space. We have a diameter which is 4,000 miles. That's the Earth's diameter. And the satellite is an additional 400 miles above the Earth. So we're going to answer a few of the questions. Name the central angle. Name the central angle that intercepts the arc covered by the satellite. So this satellite can spray down and send information to people as long as they're within this portion of the Earth. This arc, BC, is intercepted by the central angle, BDC. The length of AD was the 4,000 miles plus the 400 miles. So that's 4,400 miles. Sorry, there's angle BDC. Now, what we've talked about before, we've talked about how angle or triangle ADB has to be congruent to triangle ADC. So we know these two triangles are congruent to each other. The central angle is, this big angle is 2 times ADC. So this is getting cut in half. We're going to use trigonometry to help us figure out what that angle is. So we're going to look at our angle. We have ACD with a right angle. We know that this side is 4,400 miles long. This side is 4,000. What we're looking for is this angle. So which trig function are we going to use? Remember, we're talking about SOHCAHTOA. So if we're going to use across from the 90 is the hypotenuse, and the side next to the angle we're talking about is called the adjacent, then we're going to use cosine. So cosine of our angle, we'll call it D, that equals the adjacent over the hypotenuse. For us to solve for that angle, we need to say cosine inverse of 4,000 over 4,400. That equals the measure of angle D. So using our calculator, you need to be sure that you're in degree mode. We'll say second cosine, which is cosine inverse. You've got to use parentheses. 4,000 divided by 4,400. This is going to give us an angle of 2462. So the measurement of angle D equals 2462. What is the measure of the central angle? Well, what this 2462 is this angle right there. So we're now going to take that and times it by 2. 2462 times 2 is going to give us 4924. That's our angle right there. 4924. How many satellites would it take to cover the whole circumference? Well, if this is 2924, then the arc that we're dealing with up there, this is a central angle, so it's going to be the same degree. So this is 49 degrees out of 360 total. So we want to take the 360, and we're going to divide that by our 4924. And using our calculator, we'll see that we get 7.31. So it's going to take over 7 satellites. So it's about 7. But that doesn't quite cover the Earth. If we use 8, if 8 satellites, then there is overlap, which would probably be pretty good if that was really happening in the world.